Okay, thanks everyone for tuning into the Intact Center's TEDx Countdown event. I'm Mark Schaus, a science writer covering all of the latest new tech upgrades in clean energy and carbon capture. Upgrades that, despite the overwhelming new lows that we seem to keep reaching in the climate crisis, have nevertheless begun to become so numerous and incredible over the last few years especially, that despite all of the new lows, I believe it's still fair to talk about some faint new glimmers of hope that we have in our ability to meaningfully address climate change. So here in Canada specifically, climate change is only becoming more visible and damaging with every passing day. I mean, our country is lovingly known for its colder temperatures, and yet it was so hot in a BC town earlier this year that they topped even the record heat levels coming out of Las Vegas. It was so hot in July that shellfish were literally cooked alive on a Canadian beach. So climate change is real and it's here now. And we know what we have to do. We have to power our civilizations cleanly and sustainably, and we need to draw down greenhouse gases from the atmosphere as quickly as we can at the same time. And we really can do both those things at the scale that we need to, thanks to new science and new technology. Obviously, our progress with climate change has been just woefully inadequate to date. That's in part due to, just outright lack of action, but due in part to the fact that these are very complex challenges that we're trying to solve here. We live in a very complex society. It's not easy to just transition away from one primary source of energy that's easy and cheap and plentiful to another series of energy sources that we want to try and get as cheap and powerful and plentiful at the same time. And it's not easy to draw down gigatons of carbon dioxide from the atmosphere. But the good news is that there have been a series of new developments and new tech upgrades all across the board in clean energy and carbon capture, in everything from the obvious renewables like solar and wind to the less obvious renewables like geothermal and tidal energy, to the non-renewable but still clean energy sources like nuclear fission and fusion, hydrogen fuel, and advanced new biofuels. And just like any good portfolio, we have a diverse set of options to meet our needs in different circumstances while powering complex civilizations like ours 24/7. So, consider just the big two, solar and wind. You've probably heard that they've both only been getting better and better over the years. That's definitely true. As of June this year, it is now cheaper in nearly half the world to build and operate a new large-scale wind or solar farm than it is to operate a pre-existing coal or gas-fired power plant. Not just better for the environment or something like that, but cheaper. And that's thanks not just to government subsidies, but that's thanks to the tireless efforts from scientists and engineers all around the world working to make this equipment better, more powerful, more efficient, more durable, and longer lasting. And that, to me, is how we get to net zero. Real progress, to me, is when a lab around the world somewhere, say, makes a great new line of solar panels that would make even a climate skeptic look at them and say, oh my goodness, I could be saving how much money on my energy bill? I have got to get one of those, regardless of whatever else they might think about, the urgency of our climate crisis. But solar panels are getting just absolutely amazing in that regard. For example, one American company has a new line of solar panels out that will not only generate clean energy for your home off the grid, they will also gather the moisture in the surrounding air to run a line of clean drinking water, potentially right to your tap if you want. Great new value add for wanting to get a solar panel. Or homeowners can now enjoy advanced new solar windows, thanks to scientists recognizing that we can harvest energy from wavelengths of sunlight that we can't see while letting the visible spectrum pass through for us to see. And solar cells are not only getting more amazing all around, but we can now put them in great new locations, like on solar fences and on floating buoyant solar pads. The so-called photovoltaics totally changes the economics of going solar when you can avoid having to go and demo a huge patch of land first to make way for your big new solar farm, and suddenly more countries, maybe without as much real estate, can get in on solar so long as they have coastlines or canals. And wind, too. is seeing massive new upgrades, literally, in that scientists are building just massive new turbines, and they found it's actually cheaper to build one massive turbine than it is to build two comparably half-sized turbines with only one patch of land instead of two patches of land. And thanks to building them taller, scientists can take advantage of the stronger and more consistent wind speeds at higher altitudes to crank out more energy than two comparably smaller ones cumulatively. I mean, new turbines going up in China and Europe just next year are so big that they will actually have a blade span of about 1.3 football fields, and every one of them will power about 20,000 European homes apiece. And all of this is just glossing over, great new upgrades and other things like geothermal and tidal energy, where we now have geothermal companies, taking techniques and technology that have been honed for decades by the fossil fuel drilling industry to tap geothermal energy wells that much faster and more efficiently. And tidal energy, I mean, just this year, an Australian lab managed to double the amount of energy that we're able to harvest from the power of Earth's essentially never-ending movement of tidal waves. And we just never know when a new development like that could happen anywhere in the world and be the tide lifting all boats after that. But I mean, for all of these upgrades, it's supposedly always this elephant in the room that if we want to go with techs like these, solar and wind, that the sun is not always around and that the wind is not always blowing, that we'll need some kind of massive storage device. And we will, but once again, new science and new technology can help. So we have clever engineers from all around the world working on new innovative ways of taking excess renewable energy that we get on very sunny and windy days and putting that excess energy to use, powering up other equipment into a state of potential energy that we can cash in on later. So, I mean, here in Canada, we've always kind of had at least one solution to the, renewable energy storage problem, and that's called pumped hydro. So we harness the power of running water in a river to wash over turbines to create hydroelectric energy. But overnight, when people are using less energy, the river doesn't just slow down. We get a net excess of energy. So we take that and we pump just a little bit of the water uphill and we keep it there, waiting for the next day at like noon or something when a lot of people are using energy. We then release it onto waiting backup turbines to create excess clean energy, essentially on demand. And so other engineers from around the world are riffing on the same kind of design to, say, power up air compressors, to pump air into a confined space so that later on when the sun goes down and the wind isn't blowing, it can be vented out, and the mechanical force of moving air in a turbine, just like a wind turbine above ground, and essentially can conjure wind, I should say, on demand. Or still other engineers are working on, say, creating artificial reservoirs so they can do their own pumped hydro thing without a running river somewhere. Or we have still other Swiss engineers working on creating essentially cranes in a controlled silo environment to take excess renewable energy produced during times of plenty to hoist heavy blocks up and just keep them there and waiting for the sun to go down so that they can be slowly lowered, where a pulley system up at the top can spin a turbine-like tech and create clean energy on demand. And crucially, with every new input of clean energy that comes online, every new solar panel, every new turbine that comes online, wind turbine, that can get us closer, inch us closer to meeting our needs, even at peak hours. And every new input that comes online after that can go solidly towards banking spare clean energy for later when we need it. Now, and I mean, for all of these upgrades, it is supposedly also this elephant in the room, usually, that if we want to go with techs like these, with wind and solar, that at their end of life, and we have to, take the equipment out of service, that we'll have these mountains of green trash to deal with. But once again, new science and new technology can help, where when it comes to, for example, electrifying our vehicles. Here in Canada, for example, we already have a company that is offering a 95% recovery rate for the valuable materials in spent EV batteries. Not bad, right? And a new Swiss firm just came online also very recently. They're using materials from recycled EV batteries to make new EV batteries. So also very good. And just this year, we had an American wind energy giant give the world fully recyclable wind turbine blades, thanks to a new resin recipe they came up with that allows it to have hardened resin for use. And then when they want to take them out of service, resin can be reduced back to its primary form and then remolded into a new turbine blade. And we also already have, when it comes to solar panels, an Australian company telling us they can recover 100% of the valuable materials in spent solar panels without even using any harmful chemicals in their process. So we have the technical know-how to avoid a tsunami of green trash. All that needs to change, I mean, is just that it's still easier to take your old solar panel and just go toss it in the landfill, right? Just like it used to be cheaper to just go dump your chemicals in the harbor if you were an industrial polluter, right? All that needs to change here is our laws. And it's not like if our laws change that the added cost will make clean tech prohibitively expensive, because there's no reason to believe that these industries, recycling, urban mining, green mining, there's no reason to believe that they can't also undergo a cost-reducing trajectory like almost every other industry that could come to mind, right? And we just have no idea when advanced new discoveries and innovations will come up in this regard. Just last month, we had an American lab find a new way to take the e-waste of old circuit boards, recover the precious metals, simultaneously purge the toxic heavy metals, and have that accomplished in just a matter of seconds, right? Using 80 times less energy. So we simply have no idea when there'll be an amazing new innovation here. But for all of these upgrades, obviously we do still have the excess of carbon in our atmosphere to deal with. And we don't always need new science and technology to deal with that, but if we want to avoid some otherwise avoidable environmental crises, draw down carbon that much faster, that's where new science and technology can help. Now, the most techie of our options, I would think, probably is the direct air capture. These are those fans you've seen where the air laden with CO2 goes in one end, sorbent in water, scrubs out some of the CO2, and then air with less CO2 goes out the other side. But the technology has always been rather prohibitively expensive and at least a little bit wasteful in the large scale. The world's largest such facility, full of direct air capture machines, just went online this year in Iceland. And it's capable of pulling about 4,000 tons of CO2 from the atmosphere annually, which is very impressive, but we would also need hundreds of thousands of those facilities operating round the clock, around the year, just to put a dent in our problems. So, it likely can't and probably shouldn't happen. But there have been definitely great new upgrades in carbon capture, direct air capture. One Israeli startup has ditched the sorbent and water approach for an electrochemical approach, uses 3 times less energy, inching that towards cost effectiveness as a process. And one American lab very recently has come out with a new series of filters that are so fine that they can capture individually sized molecules where CO2 in a gas, a specifically sized molecule like CO2 could be captured by the filter while the other air passes through, uses 60% less energy than traditional capture tech. So also just fantastic. I know that it usually has been, and it still is, in vogue in some environmental circles to kind of dunk on direct air capture as just another sign of, human hubris. But this could be an indispensable tool in our toolkit for drawing down carbon very quickly. On the naturalistic side, certainly we can just plant more trees and, take care of the ones that we have. But there's also a saying in forestry: the best time to plant a tree is 50 years ago, right? We need the trees right now. And believe it or not, there is some fancy new technology in afforestation, I should say. We now have fully or semi-autonomous drones that can fly over terrain, scan that terrain, create a 3D vegetation map using LiDAR, sync that information to a satellite in orbit, queue up thousands of individual drop sites into which they can fire germinated seed pods, essentially canvassing an area, planting trees about 10 times faster than we, frail humans can by hand, and in potentially more remote locations and dangerous locations. And if the climate scientists are right that we would need in the high order of hundreds of billions of new trees to really put a dent in our problem, it's good news then that there is a British company out there saying we can plant hundreds of billions of trees using precisely this technology by the year 2050. As long as we don't do something stupid like monocrop all of the trees together, or kill the local biodiversity, or create some kind of unholy albedo effect or something like that. But we can plant hundreds of billions of trees if we need to. And we can also make the naturalistic process easier on ourselves. So we have one American company that is crossbreeding and hybridizing genetic material from different kinds of trees, where we can see that some grow very fast. We want to introduce that trait into more that we might plan on foresting large new regions with, get them grow a bit faster, store more carbon in the soil. And they tell us that there's about an 18% increase in carbon storage in soil going with that approach, which would be an 18% reduction possibly of the amount that we need to, that we would need to plant. Another American lab is working on developing root crops, engineering new root crops to have more diffuse root systems that stretch further into the soil and store more carbon in soil as a result. And they're telling us anywhere between 20 and 40% increase in carbon storage in the soil. So that's, we're just chipping away at that massive amount that we would need to plant otherwise. And root crops needs to be part of our agricultural cycle anyway. So, I get it. Technology is no panacea for a mess that technology largely got us into. And the best carbon capture strategy is still just not pumping it into the atmosphere in the first place. But on their own, new innovations like these can really start to push the needle just a little bit. And taken together, all of them piling up now, they're starting to become game-changing. Okay, thank you.